Where does ATP come from? Okay.
Chemiosmosis.
And once that ATP is made, along with that NADPH, what are those two compounds used for? What are they used for, Neil?
Converting it into glucose.
They're converting the energy into glucose, which is correct, because that's the final step. And what's the name of that process, Veronica? Of making glucose. So that process where we take the energy and we make it into glucose, that's called what? The Calvin cycle. All right, but let's go back. So the production of ATP is called chemiosmosis. Chemiosmosis should have been one of your flashcards that you guys made the other day. Did everybody make those flashcards? You should. Process relies on a concentration gradient of protons across the membrane. The concentration of protons is high inside of the grana, or the thylakoid. Proton concentration is really high inside. So for example, this would be the thylakoid, the classroom. You guys would all be protons, right? Concentration is high inside of the classroom, correct? So when it is time, everything does what? Goes down the concentration gradient. So we go from high to low. That movement of protons brings together ADP and what? And P. ADP and P together make what?
ATP.
ATP. Why do we need to go through all this? If we have our carbon, why can't we just go straight from carbon straight to glucose? Does anybody know? I'll tell you why. Okay? So if you wanted to bake a cake, there's certain ingredients it takes to bake a cake, correct? All right? There's flour, sugar, there's the cake batter, eggs, so forth. Okay? You want to bake a cake for your best friend. Would you just put a bowl of flour in front of your friend and tell you, here's your cake?
Yes.
Yes.
Now, some of you might. But no. Carbon dioxide, flour, same scenario. They have to be refined before they can actually be used. Yes, flour is an ingredient for the cake, but it's not the product that you wish to have. Before we even talk about alternative pathways, does anybody know why we have alternative pathways?
Because different plants are in different conditions. Like plants that are in deserts need to store more water, so they follow the CAM pathway.
Exactly. Plus 2 test points. You already gave away my lesson. CAM. Granulation acid metabolism. These plants aren't messing around. Their stomata is closed completely during the daytime. So you're thinking about plants that would normally be in the desert, and they know that the conditions are way too dry, and they don't want to lose any of the water that they've been able to gain. Okay? So they only open at night. All right? Now, what's the problem with being a CAM pathway plant? Yeah. You can't grow as quickly. Okay? You're going to be relatively small. The egg osmometer lab. Okay?
Is that what?
This is the one that I told you guys about weeks ago. We finally get a chance to do it. The materials are up front. All right? If you need any help whatsoever when going through this lab, please do not hesitate to let me know. Each group gets 2 eggs. If you go through your 2 eggs, it's like Mr. Williams, I broke both of my eggs. Let me know. If we have an extra, we will give it to you. Then we're going to use this end to break the bottom of the egg. There is a very thin membrane right beneath the shell. You do not want to pierce the membrane. If you pierce the membrane, the lab will not work. You want to remove enough of the shell around the bottom of the egg the size of a quarter. Got it? Once you've done that, then you're going to crack the top of the egg, take one of your straws, which are here, measure it out, and stick it to the top of the egg. Then you're going to use the hot glue gun, which is on my desk, to seal the edges of the straw around the egg. Then you're going to take your beaker, you're going to fill it to the brim with water, and you're going to sit your egg on top of it. Okay? And then you're going to measure the rate of osmosis. Got it? Which is why it's called the egg osmometer. Now I'm pretty sure you're going to have quite a few questions as the lab goes on. Do not hesitate to ask. This. There you go. Go slow and make sure you, because if that gets caught in that membrane, it's going to tear it, so be careful.
Can we do a meditate? A little egg.
You did it! And this is the membrane of the egg. It is very
That's
delicate.
excellent. Perfect. Good job. You guys ready to go to the next step?
What?